Alright, so if you haven't read problem number 9, go ahead and pause the video and read it. This is from the chapter 7 review. And to solve this, it's just part C from this problem that I chose from a FRQ released AP test. And to solve part C, you have to do separation of variables, but notice that they give you an initial condition. So we separate the variables by doing that. So now we have dW is equal to 1 over 25 W minus 300 dt. And if I divide both sides by W minus 300, I now have this. So remember that the main thing with separating variables is you want to gather, in this case, the W's with the dW's, and we don't have a variable t, but 1 over 25 dt is real easy to integrate when we separate and integrate both sides. Now, 1 over W minus 300 is a simple U substitution. So what we have is, if we let U equal W minus 300, du with respect to W is equal to 1, and du is pretty much equal to dW. Some of you guys that are really good with U substitution might have figured that this step that I just did is kind of pointless, because if you do it in your head, this is 1 over U, and dW switches to du right away, so it's just 1 over U du, or when you integrate that, that's the natural log of U, which is the natural log of W minus 300. Integrating 1 over 25 is, and it's with respect to t, so 1 over 25 t. Don't forget the plus c, you only have to do plus c once. Now what I'm going to do is I'm going to raise both sides to the power of e, or to the base e. Raise both sides to the base e. So then now I have the absolute value of W minus 300 is equal to, this is e to the 1 over 25 t, that's 1 over 25 t plus c, or times e to the c. Remember that this is just a constant. So we have the absolute value of W minus 300 is equal to c e to the 1 over 25 t. Again, I know it's hard to see, but that's 1 over 25. And to remove the absolute value bars, it's just W minus 300 is equal to plus or minus e to the 1 over 25 t. Oh, I forgot my c. So we have enough information to solve for c. So given the initial condition of W of 0 is equal to 1400, that is, given t is equal to 0, W is equal to 1400, we just plug that in and we get 1400 minus 300 is equal to plus or minus c times e to the 1 over 25 t. Do the work And you should get that C is equal to 1,100. And it's positive. And we know it's positive. Yeah, it's positive. And let me just go ahead and rewrite this as W minus 300 is equal to 1,100 e to the 1 over 25t. And then when I add 300 to both sides, I have W is equal to 1,100 e to the 1 over 25t plus 300. And that is the answer. So t in this little part, t should have been 0. So that's e to the 1 over 25 times 0, which is going to be e to the 0, or just 1. And 1,400 came from that. Alright, I also want to go over from the first chapter 6 review that I gave you. Problem number 8. I want to go over these types of problems only because I noticed a lot of students were getting this problem wrong on the chapter 6 test, and I want to clear up any confusions for the retake. So one thing you had to do was use this key and the the fundamental theorem of calculus to determine this. Okay, so if g of x is equal to the integral from 1 to x of f of t dt, the derivative differentiating both sides using the fundamental theorem of calculus, we know this. Okay. However, I think I'm getting a little ahead of myself because on part A, you don't need this yet. We'll need it for part B. Okay. So to find g of 2, all we're going to do is plug in the 2 for x here. So I'm going to backtrack and talk about the original g of x. And to find g of 2, we do g of 2 is equal to the integral from 1 to 2 of the function f. So all we're doing is looking at the area from 1 to 2. And it is negative. Now, go ahead and use the area of a triangle. And you'll see that you get negative 1/4. One thing you might be wanting to ask yourself, or you might be asking yourself, is how do I know that that height came out to a height of negative 1/2? Well, if you use the slope of down 1 and to the right 2, so down 1 to the right 2, we have a slope of negative 1/2. And if we go down to the 1/2 point, or where x is negative 1/2, we can go down 1/2 point, or half, and to the right 1, because that'll still give us the slope of negative 1/2. So down 1/2 and to the right 1, that'll create this point, negative 1/2, comma 2. And when we plug that in, we have a base of 1, a height of negative 1/2, and a base of 2. I'm sorry, not a base of 2, that's part of the formula. We get negative 1/4. When we do g of negative 2, we have to go ahead and do the integral from 1 to negative 2. And that's a problem. We can't have the lower limit bigger than the upper limit. So a simple fix is one of the properties that you learned when integrating. We can literally switch this around. However, now we have to write a negative. We have to do the negative of that integral. So we can literally rewrite the integral from negative 2 to 1, so that now we have the lower limit that's bigger. I'm sorry, the lower limit that's smaller and the upper limit that's bigger. However, we have to do that negative part here. And once we do that, we know that we're talking about the integral from negative 2 to 1. So that's the triangle and this half circle. Okay, and once you do the work, you might get something like this. It's 3 over 2 minus pi over 2. It's just a negative of it. And when you distribute that negative, you get pi over 2 minus 3 over 2. Part B isn't too bad if you remember that taking the derivative of this, so g prime of x will give you f of x, and that isn't bad at all, because that implies that g prime of negative 3 is going to give me, it's going to be the same thing as f of negative 3. And we know f of negative 3 is just input output. When x equals negative 3, what is your? So we get 2. So for the second part, g double prime of negative 3, we have to take this g prime of x equals f of x and then differentiate that. So differentiate both sides, we get g double prime of x is equal to f prime of x. Okay, so this is now our key, and writing g prime, or I'm sorry, g double prime of negative 3 is the comparison of f prime of negative 3. Now, now we got to look at f prime of negative 3. The reason is because we were looking at the graph of f, not the graph of g. So we got to get our answer by looking at the slope at x equals negative 3 using the graph of f. So the slope is, well, here's x equals negative 3, which happens to follow this line, which has a slope of up 2 and to the right 2. So it's a slope of 1. So if the slope is 1, that means our answer is going to be 1. That means that anywhere on this line we have a slope of 1, even when x equals negative 3. And I ran out of time. I will have to go over the next two in a different video.